We've been promised realistic digital humans for, like, decades, but they always seem to fall just a little bit short. Well, today we're diving into a new research paper that might have finally actually cracked the code. And I'm telling you, what you're about to see is so real, it might just break your brain a little. We've all felt this, right? For years, we've been stuck in that uncanny valley where digital characters just look off. Their skin has that weird plasticky sheen, and their hair, it just doesn't move or catch the light in a way that feels real. It's a problem that has plagued computer graphics pretty much forever. So, the big challenge, the holy grail, has always been this. How do you capture a real person so perfectly that you can just drop them into any virtual world and they look completely, 100% convincingly real? Yeah, the dream is basically a magic mirror, some kind of technology that doesn't just scan you and build a 3D model, but one that perfectly simulates how light actually interacts with you. Think about your skin. Light doesn't just bounce off it. It goes in, bounces around under the surface, and then comes back out. That effect, it's called subsurface scattering, and it's the absolute secret to realism. It's also incredibly hard to pull off. But now, this new paper comes along making some absolutely incredible promises, claiming they've finally done it. So the big question is, does it actually deliver on this seemingly impossible goal? Okay, let's take a look. All right, moment of truth. Does this new technique finally pull us out of the uncanny valley? Let's see the results for ourselves. Whoa. Okay, the answer is a resounding yes. Just look at this. The way the light hits the skin, those subtle little changes in tone, it's just stunning. And get this isn't just a static picture. These are fully rendered characters that can move around, be put in any environment, and the lighting just reacts perfectly. And the hair! Oh my goodness, you have to look at the hair. This is a massive, massive breakthrough. My brain is genuinely telling me I'm looking at a real person's hair. Is it perfect? Not quite. But it is so far beyond anything we see in even the most advanced video games today. It's crazy. And here, this is where it gets really nuts. On the left, that's a photo of the actual person. On the right, that's the virtual model. I mean, at first glance, you might think they're the exact same image. Now, if you really zoom in, you can spot some tiny differences. A detail on the shirt, a few stray hairs. But the fact that you have to hunt for them, that's what's so incredible here. Okay, I have to know, how is this wizardry even possible? It feels like magic. Well, it turns out there are two key secrets to making this all work. And the first one has to do with how you build the scene in the first place. You see, for decades, computer graphics have been built using meshes, which are basically millions of flat little triangles stitched together. This new method just throws that whole idea out the window. Instead, it builds everything from millions of tiny, kind of fuzzy 3D bumps. Think of it like a point cloud, but every single point is a soft, semi-transparent little blob. So why the big change? Well, trying to render thin, fuzzy stuff like hair with flat triangles is a total nightmare. It just never looks right. But these Gaussian bumps, they can overlap, and each one can have its own level of transparency. This makes them absolutely perfect for capturing those soft, complicated details. Now, there is a trade-off. It uses more memory, and it's a lot harder to go in and edit a cloud of points than it is to sculpt a solid mesh. Okay, so Gaussian spotting totally solves the hair problem, but skin is a completely different animal. It's not made of a bunch of thin strands, so to make skin look real, we need a second and honestly even more clever invention. Remember that subsurface scattering thing? Most games still treat skin like it's a painted wall. Light hits it and it bounces right off. But that's not how it works. Real human skin is translucent. Light goes in, scatters around, and then comes back out. Nailing that effect is the absolute key to realism. So the old way of calculating this, a technique called spherical harmonics, it was incredibly slow. The best analogy is to imagine that every tiny point on the skin has a miniature disco ball on it. This disco ball has 81 tiny mirrors, each one trying to catch light from a different direction. Every time the character moves, even a little, the computer has to recalculate all 81 of those mirrors for every single point on the skin. This creates something called cubic complexity, which basically means if you want to double the quality, you have to do 8 times the work. It's not practical. And this is the brilliant cheat code in this new paper. Forget the disco ball with 81 mirrors. Instead, imagine every point on the skin has just 3 tiny little laser pointers. Now, instead of tracking 81 different reflections, the computer only has to track where 3 simple beams of light are pointing. This turns that computational nightmare of cubic complexity into a simple, linear problem. The whole thing becomes incredibly fast. It's a genius shortcut. And for the final piece of the puzzle, they sprinkle on just a little bit of neural network magic. What's funny is they use a pretty old-school type of network, a convolutional neural network, which the researchers themselves jokingly call grandpa stuff. But it's perfect for this one job. It just looks at the person's pose and really quickly predicts where the shadows should be. It's light, it's fast, and it works beautifully. So you've got Gaussian splatting for the hair, you've got the laser trick for the skin. It all sounds amazing. But I did mention there was some bad news, didn't I? And yeah, here it is. First off, to capture all the data you need to create just one of these avatars, you can't just use your phone. Oh no, you need a room-sized, custom-built dome. And inside that dome, you need to stick 500 high-resolution cameras, all firing at the exact same time. But wait, there's more. On top of all those cameras, the rig also needs 1,000 individual computer-controlled lights. This is how they capture the light hitting the person from literally every possible angle, which is what gives the final result that crazy realism. So what's the price tag for this whole sci-fi setup? Well, the estimate is somewhere between $500,000 and a full $1 million. And that's just for the physical hardware. That's before you even think about the supercomputer you're going to need to process the mountains of data it creates. That sounds like a complete deal breaker, right? Like this tech is just going to be locked away in a few fancy labs forever. But that's really not how this stuff works. This is just the very first step. And this brings us to what I like to call the first law of research papers. The first paper, its only job is to prove that something impossible is now possible, no matter how much it costs or how slow it is. Now that they've done that, now that we know it can be done, future researchers are going to focus on making it faster. And then the ones after that will make it cheaper. It might take a few years, but eventually this kind of tech could be running on the phone in your pocket. And that leaves us with a really fascinating thought. Just imagine that for a second, a nearly Hollywood-quality virtual version of yourself accessible right from your phone. What happens to video games, to how we communicate online, to our whole idea of a digital self when that technology is in everyone's pocket? What an absolutely wild time to be alive.